The learning objectives for today are to solve exponential equations and to solve exponential inequalities. Solving exponential equations. What are the exponential equations? Well, in an exponential equation, you will find a variable in the exponent. For example, 2 to the power of x equals a to the power of 3, or 3 to the power of 7x minus 3 equals 9 to the power of 2x. By the end of the lesson, I hope you will be able to solve these two yourself. We will use a very important property for solving exponential equations, and this is the property of equality for exponential functions. Let's see what it is. When we have a positive b number which is not equal to 1, then b to the power of x equals b to the power of y, if and only if x equals y. If and only if statements always have two statements hidden. One statement is if 3 to the power of x equals 3 to the power of 5, then x equals 5. The other statement is if x equals 5, then 3 to the power of x equals 3 to the power of 5. I hope you notice that we have the same base on both sides of the equation. That's very important. You can only use this property if this is true. Usually we will use this first statement when we are solving exponential equations. Let's see an example. Now let's see step by step how to solve exponential equations. Here we will solve these two. As you see, they are both exponential since the variable is in the exponent. We'll start with this one. Let's copy down the original equation first. And as I mentioned on the previous slide, here you notice that the base of the two exponents are different. So we need to change it to be the same. We can rewrite 9 as 3 squared. Now we simply need to deal with power of a power, which I hope you remember is to multiply the exponents together. So therefore we will receive 3 to the power of x equals 3 to the power of 8. Now we can use the property of equality for exponential functions, and we can state that x equals to 8. Now let's solve the second equation. Here we have very similar steps since we have different bases, but we can rewrite 4 easily. So let's rewrite 4 as 2 to the power of 2. And now, again, we need to use the power of a power, which means I need to multiply 2 by this expression. So therefore, I will get 2 to the power of 5x equals 2 to the power of 4x minus 2. Now we can use the property of equality for exponential functions. So therefore, we see 5x equals to 4x minus 2. We simply need to subtract 4x from both sides. So we end up with x equals negative 2. Now this is your turn to try. Please pause the video and press play once you have your answer. And the answer is... Let's see a real-world application for exponential functions. Well, sometimes we can use information about growth or decay to write an exponential function. Let's see this question. Khadija starts an experiment with 7,500 bacteria cells. After 4 hours, there are 23,000 cells. First task is to write an exponential function that could be used to model the number of bacteria after x hours if the number of bacteria changes at the same rate. Second part, how many bacteria cells can be expected in the sample after 12 hours? In this part, we need to find an exponential function that could model the number of bacteria after X hours. What do we know? Well, we know that the starting number of bacteria cells is 7,500, and we also know that this means it's 0 hours after we started the experiment. We also know what is the form of an exponential function. It is y equals a times b to the power of x. If we note this down, we can identify each part. Since we're looking for the number of bacteria cells after x hours, this means y is the number of bacteria cells. X is the hours passed after we started the experiment. A will be the number which belongs to the 0 power, which is the starting number of bacteria cells. That is 7,500. And we need to find B. Let's see, how do we find that? Well, we simply need to substitute all the values that we have and belong together. If we use the 4-hour data, which is x equals 4 and y equals 23,000, and also we know that a is 7,500, then we simply need to substitute into our equation and solve it for b. So we need to divide by 7,500 and take the 4th root of each side. Use the calculator to get the approximate value for b, which is 1.323. Now we simply need to insert this data into the original equation and keep our two variables, which are y and x. So therefore our equation is y equals 7,500 times 1.323 to the power of x. In part B, we need to find out the expected number of bacteria cells after 12 hours. We can simply use the equation that we just received on the previous slide, which is this one, and this time we have to use 12 for x, because we want to know how many bacteria cells we have after 12 hours. So let's insert 12 into x and type it into the calculator. We get this. This means that after 12 hours we get approximately 215,665 bacteria cells.
Now, before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom, where we cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. The first session is always free. So if you are interested in a free lesson, click the link in the description below. To book a lesson, you can always send us a direct message on Instagram at Mr. Mathematics. Okay, with that said, let's get back to our lesson.
Now this is your turn to try. Please pause the video here and press continue once you have your answer. And here is the answer. And this is part B of the previous question. You can use the equation from the previous slide. Please pause the video again and press continue once you're ready to check. And here are the answers. Here is the equation from the previous slide. We used 12 as it was 12 years. And we substitute. Since we're talking about population, so human beings, we need to round it to get a whole number. So therefore our answer is 28,411. How did you do? There is another application of the exponential functions, and that is the compound interest. Compound interest is an interest paid on the principal of an investment and any previously earned interest. Here is the formula for it. This is the amount after the interest is calculated. Principal is the invested money. We have to have a 1 in here. R is the interest rate. So whenever you hear a percentage for the interest, you need to change it to decimal, and that number comes in here. N is the number of times the interest compounded per year, and T will be the time in years. So let's say if we have an interest compounding twice a year, then N equals 2 and T equals the amount of years after I want to take out my money. Let's see an example for this. An investment account pays 5.4% annual interest compounded quarterly. If 4,000 dirham is placed in this account, find the balance after 8 years. What do we want to find? We want to know how much money we have after 8 years. What is our plan? Well, our plan is simply to use the compound interest formula, which is this. Let's identify everything. The amount is what we're looking for. P, the principal, is the money we invest, which is 4,000 dirhams in our case. Interest rates will be 5.4%, which we need to change into a decimal. So we need to divide this number by 100 in order to get a decimal. Number of times interest is compounded per year. It says interest compounded quarterly. These words mean every quarter of a year, so therefore it means 4 times a year. And T is the time in years, which we know it's 8 years. So we already have everything that we need. P equals 4,000, R equals 0.054, N equals 4, and T equals 8. So we don't have anything else to do but substitute into this formula. So we have our formula and our values. We simply need to substitute in. Here we go. And we need to type into the calculator. We get 6,143.56. So therefore, the balance after 8 years will be 6,143.56. Now this is your turn to try. Please pause the video and press continue once you're ready to check your answer. And the answer is the formula. I hope you managed to identify the variables. This is the substitution, and our answer is this. How did you do? Let's focus on our second learning objective, which is solving exponential inequalities. An exponential inequality is an inequality which involves exponential functions. For example, 4 to the power of 3x plus 2 is smaller than 64, or 2 to the power of x plus 2 is greater than 1 over 32. Here we will use property of inequality for exponential functions, which is very similar to the property of equality for exponential functions. This time we will have inequality sign between both the exponential expressions and the exponents only as well. As you see, we can use it for both greater than or smaller than signs. Here is this inequality that we need to solve. I will copy down my original inequality. And I hope you notice that here we have 243, which is not the same number as 3, but we can change 243 to become a 3 power. So let's change it to 3 to the power of 5. So we will see this. I hope you remember 1 over 3 over 5, 3 to the power of 5, will be actually 3 to the power of -5. And now we can use the property of inequality for exponential functions. So we see 2x minus 1 is greater than or equal to -5. And simply we just solve this inequality by adding 1 first and then divide by 2. So here we get x is greater than or equal to -2. And now this is your turn. Beth and Liz tried to solve this inequality. Your task is to figure out if either of them is correct. Go through their work and see whether they made any mistake. If they did, also note then what is the mistake. Now please pause the video and press continue once you are ready to check. How did you do?